Hey, welcome back to The Explainer. If you're here to really dig into Java, you're in the right place. We're not just learning to write code, we're learning to build things that are powerful, professional, and secure. And today, we are tackling one of the absolute cornerstones of that skill, encapsulation. Honestly, this is one of those concepts that separates the casual coder from the pro. So, let's get right into it.
Just take a second and really think about that. What if you built an entire application and any little piece of it anywhere could just reach in and change the fundamental rules? Like a bug in the settings menu could suddenly change a player's score to 1 billion, or an error in the login system could accidentally wipe out a bank account balance. It would be total chaos, right? Well, that is the exact problem that encapsulation was born to solve.
So to kick things off, let's take a look at what that chaos, what I call code in the wild, actually looks like. This is the world where your data is just out there, totally exposed and vulnerable to all kinds of bugs and unexpected changes from every corner of your program.
Okay, check out this super supple bank account class. See that little word public right next to balance? That is a massive red flag. It's like leaving the door to a bank vault wide open. Any other piece of code anywhere in your entire project can directly reach in and change that balance variable to whatever it wants. -100? Yep. Some random text that makes no sense? It might crash, but it can try. There are absolutely no rules, no checks, no protection. This right here, this is how you get those nightmare bugs that take forever to find.
But don't worry, because into this wild, chaotic world steps a hero. A guardian for our code, whose entire job is to enforce the rules and protect our precious data from the outside. And its name? Encapsulation. This is the principle that's going to bring order, security, and a real sense of professionalism to our code.
Now, if you look up the official definition, it'll say something like it's about combining data and the functions that work on it into a single unit. And yeah, that's true, but what it really means is we're bundling our data, like our account balance, together with the only approved methods that are allowed to touch it. Everything gets neatly and securely packaged together.
You know, the best way to think about it is like a medicine capsule. The actual medicine inside, that's your data. And the plastic shell around it, that's your class. Now, you don't just crack open the capsule and throw the powder everywhere, right? Of course not. The capsule is designed to deliver that medicine in a very controlled, very safe way. And that is exactly what encapsulation does for your data. So how does our code guardian actually get the job done? Well, like any good guardian, it has a specific set of tools and a very clear process it follows to keep our code safe. Let's open up that toolkit and see what's inside.
Is really just a simple 3-step plan. First, you lock your data away. You declare it as private, which basically makes it invisible to the rest of the program. Then, you create a public getter method. This is like a little window that lets other code ask what the data's value is. And third, you create a public setter method, which acts as a secure front desk for other code to request a change to that data.
You know, that bank analogy we started with is actually perfect here. Just think of your private data as the money locked away inside the bank vault. Super secure. Nobody just walks in. Your public methods, on the other hand, are the front door and the bank tellers. They're the official, controlled entry points where you have to go to make a polite, structured request to interact with what's inside the vault.
All right, enough theory. Let's see our code guardian in action with a real practical example. This is where you're going to see just how simple, but also how incredibly powerful this all is when you put it into practice. So, here we have a programmer class, and notice the very first thing we did. The name variable is marked private. Boom, step 1 is done. The vault is locked. No other class in our program can just reach in and grab or change programmer.name. It's totally hidden.
Okay, step 2. We add our public getter. This little method, getName, is our safe viewing window. Any other part of the code can call this method and politely ask, hey, what's the programmer's name? And our class will just return the value. It's providing controlled, read-only access.
And finally, here's our setter, setName. This is like the secure deposit slot. We can pass a new name to this method, and the class itself handles the job of updating the private name variable. Now, the really cool part is, this is where we could add our own rules. We could add code here to say, hey, don't allow a name to be blank, or make sure the first letter is capitalized. We are completely in control.
So how do we actually use this thing? Well, we create a new programmer object. And instead of trying to do p.name directly, which, by the way, would give you an error now, we use our public methods. We call p.setNameGeek to set the value, and we use p.getName to get it back. See, we're going through the front door, playing by the rules.
And of course, when we run it, the output is exactly what we expect it to be. The data was protected, the access was totally controlled through our methods, and our code works perfectly. But now it's also way safer and much easier to manage.
So just by understanding this one concept, you've basically just unlocked a whole set of programming superpowers. And I'm not talking about small stuff. These are huge advantages that are going to make your code dramatically better.
So first off, you get data hiding, so you can protect sensitive information. You get enhanced security, because now you can add validation inside your setters. And this one is huge. You get incredible maintainability. You could totally rewrite the inside of the programmer class, but as long as getName and setName still work, none of the other code that uses it will ever break. On top of all that, your code becomes way more reusable and neatly organized. This stuff is what separates good code from truly great professional code.
Now, with any great power comes the need to, use it wisely. Encapsulation is amazing, but it's important to understand the best ways to use it and the, let's say, minor trade-offs that come with it.
Okay, let's just be honest. Writing getters and setters for every single variable, yeah, it adds a few more lines of code. And technically, calling a method is a tiny bit slower than just accessing a variable directly. But here's the secret the pros know. For 99.9% of apps out there, these so-called disadvantages are completely meaningless compared to the massive wins you get in security, maintainability, and just building code that doesn't fall apart.
So here are the new rules to code by. First, always default to private. Make things public only when you have a good reason. Second, always use methods to expose your data, never public fields. Third, put your validation logic, your rules, inside your setter methods. And finally, think about it. Does this piece of data really need to change? For something like a user ID, you might only create a getter and no setter at all. That makes it read-only, which is just smart, secure design.
And that's pretty much encapsulation in a nutshell. It's a fundamental shift in thinking, from writing messy, chaotic code to building structured, secure, and truly professional Java applications. You now have the tools you need to be the guardian of your data. So the only question left is, what are you going to build with that power? Thanks so much for watching.